Welcome to BKSS Academy. Now we will discuss about hazards in pipelining processes, pipelining CPU, and it is of computer architecture. First, we will know stall. Stall is the latter instruction depends upon output of the earlier instruction. Suppose one operation is going on in the CPU. So next instruction when it will come, that is I1. This is I1 is executed in the CPU. I2 is coming for processing when its output of I1 is depending on the I2. That is the stall. A pipeline hazard occurs. A pipeline hazard occurs when the pipeline or some portion of the pipeline must stall because conditions do not permit to continue the execution. When it is on the waiting mode of the recent process to be processed, that is called pipeline hazard. The hazards are of three kinds, that is structural hazard, data hazard and control hazard. More than one instruction, structural hazard is more than one instruction try to access same resource. If same resource is accessed, that may be hardware, that may be CPU, that may be RAM, that may be any register. So when more than one instruction is accessing the same resource, that is structural hazard. Hardwares cannot support certain number of or combination of instructions, that is the structural hazard. Similarly, data hazard is of three kinds, that is write after read, read after write, and write after write. These are the dependencies. Instructions depends on results of prior instruction. So previous processing, what the result is coming, that is depending on the current instruction to be executed. Still on pipeline. So J depends on instructions I's result. Instruction J depends on instruction I's result. So read after write, when instruction 1 is there, when instruction 1 R3 R1 plus R2 will be stored in R3, then R5 R3 plus R4 will be stored in R5. So R3 will wait till this instruction is executed. This is called as the read after write. Similarly, write after write. Suppose R1 into R2 will be stored in R3, R4 and plus R5 will be stored in R3. It will be written in R3, then after it will be written in the R3. This is write after write. Write after read, add R1, R2, R3, that means R2, R3, R2, R3 will be added to R1. This will be addition. R1, R2, R2, R3 will be added, then that will be stored in R1. Then sub R2, R5, R4, that means R4, R5 will be stored in R2. That means write after read. First we have to read, then we will go for write. This is the example. Similarly, control hazard is, it is caused by delay between fetching instruction and decision about changes in control flow. Its example is branch and jumping. Thank you.